All right, well, Bruce will be leading off our sessions today, and let's see, particularly he'll be talking about how we can take the role of restoration from small-scale provincial discipline to a broader global practice, identifying some of the constraints that exist which keep us from achieving all we could otherwise. Please join me in welcoming Dr. Bruce Pavlik, our first speaker, and the 2013 Honorable John C. Pritzlaff Conservation Award recipient.
I'll be mindful of time. Well, first of all, I have to say what an honor, and I really appreciate Mrs. Pritzlaff, who presented me with the award last night, and to Steve and his staff at the Santa Barbara Botanic Garden, and to my colleagues who said such very nice things about me, and also who took time to come and deliver their talks today. So I really very much appreciate that. I am going to be talking today about my sort of my experiences that I've had, the insights that I've gained since taking the job at the Royal Botanic Gardens Kew, which was a little more than 3 years ago. Taking that job has allowed me to basically take my California experience and apply it in other realms where maybe some of the ideas that come forth in California haven't been heard before. And you know, you get various reactions, good and bad, to those ideas. Sometimes they are a little bit out there, and that really has allowed me to kind of step back and say, well, restoration ecology and ecological restoration, and I'm not going to make that distinction in my talk today. I'm just going to call it all ecological restoration. Ecological restoration has this great promise and power. It is constrained currently, and I'm really going to suggest just a few ideas of why I think it's constrained. It could be constrained technically or institutionally, financially, psychologically, but I'm really interested in hearing what my colleagues have to say, what constrains them in their projects. And so hopefully we'll have a discussion to that effect later on. And then I'll make some suggestions on how we go to the next level, how we take sort of a regional, provincial discipline, restoring small-scale ecosystems, and how we make it relevant globally. So, ecological restoration, promise and power. As I think you all know, the definition of ecological restoration is the process of assisting the recovery of an ecosystem that's been degraded, damaged, or destroyed. That's from the Society for Ecological Restoration. And the underlining there indicates something very important, which is it's a real active interaction. It's something where we really engage with nature. And so it ultimately is informed, and it's sensitive, and it's mutually beneficial between people and nature. And therein, I think, lies the promise. It's science-driven, it offers healing for the planet, and it offers hope for humanity. And not only is there promise, but really in the last 20 and 30 years, there's been tremendous power put behind the idea of ecological restoration. And I could make a very large list of all of the various ways it's been incorporated into policy documents at all scales of government, from the UN right through to the U.S. Forest Service, to the European Union, locally, globally. There are many ways where the idea has been now fully embedded in how we're going to look at the environment and heal the damage that we've caused. So these are just a few of examples. The UN Environment Program, the Convention on Biological Diversity, and the Global Strategy for Plant Conservation has 2 targets that are directly relevant to restoration, targets for ecoregions or vegetation types, and targets for plant species. And so these are goals that the UN has set. The U.S. Forest Service has gone from the idea of reforestation to the idea of restoration, and they're building restoration into their Forest Service manual. The EU Sustainable Budget, the EU has many ways that they've incorporated ecological restoration, but they've actually put it in a budget document, and so they're calling for the ecologically sound restoration of degraded lands. So these are very, very powerful ways of saying that this is an important discipline whose time has arrived. So why aren't we doing better, or how can we do better? How can we amplify our effect on the planet? One way to approach this issue is just to identify constraints. And again, these are not all the constraints. They're just some things that I thought might illustrate how we could think about it. Okay, I'm getting some changeover of my presentation here, going from Mac to PC, so I'll work with it. The first thing that biologists will tell you is that, you know, the one reason we're constrained technically is that natural systems are incredibly complex. And that's true, and so that's the importance of doing basic research for ecological understanding. Nobody is going to deny that. Those systems will always be more complex than we have the ability to sort of ascertain. Even single species restorations are challenging. But within the last 20 and 30 years, we begin to accumulate successes. And there's a book by Joyce Mashinsky in 2012 that talks about restoring single plant species and where the successes and failures have been. And so I think, you know, we're at the point now where we've got a project registry run by the Center for Plant Conservation. They've got guidelines. We've been able to do single species restorations. And I could pull out a whole list of ones that are generally regarded as successful. This is just a small sampling, everything from palm trees to little tiny plants that grow along the shore of Lake Tahoe to cliff-dwelling plants in Oregon. We're learning, and we're doing a pretty good job on learning how to do this. It doesn't mean it's without a challenge. It just means that we have really made progress in the last 20 years. And not only for single species, but, you know, habitat manipulations are becoming more successful. So here's an example of something I just visited up at the UC McLaughlin Reserve, where they're able to restore serpentinite forb fields by removing goat grass. And they use a variety of techniques: fire, some grass-specific herbicides, some weeding. And again, this is really important, and a huge change then in the floristic composition of a natural community. Even tropical forests, which are regarded as the most difficult because they're so species rich, we are able now to find techniques, templates for doing restoration. And this is one thing I wanted to tell you all about. This is a book that's just been published as of this month. It's written by a colleague, Kate Hardwick, and her collaborators on restoring tropical forests. And what they're emphasizing here is a restoration template called the Framework Species Approach. And this is a template that can be imposed on many different tropical forest types. It's not just specific to one type. So it's globally relevant. It's practical. It's not theoretically based. It's been translated into multiple languages, and it's available now. And I'll show you a project that she and Steve Elliott worked on in Cambodia to explain what the Framework Species Approach is. The Framework Species Approach does not go in and say, let's restore every species in the tropical forest. Let's find a mixture of effective species that help do the healing themselves. So we might begin only with 20 to 30 species, and these are identified in greenhouse studies that are done in situ, in other words, in the same climate as the restoration. They find species that have high survival rates ex situ, that have rapid growth rates. And the rapid growth rates are really important because one of the big problems in the tropics is the effect of grasses that come into a place, an area that's been deforested, and they now elevate the fire danger. So it's almost impossible in that kind of system to get trees reestablished by themselves because of the reoccurring fires. So these are species that are dense and spreading and rapidly recapture the site from weeds. And so this is a good example of a species that is recapturing this habitat and reducing grass cover and reducing fire frequency. The other thing that framework species do is attract seed dispersers. And so that is how other species eventually get added to the restoration, because birds and mammals that naturally bring in seeds will do so when they're attracted to the restoration site. So that's a very, very important element in getting species richness up again in a tropical restoration. So the other interesting thing is it's not a successional approach. It doesn't sort of look at pioneer species and climax species and assume that it's going to be the pioneer species that are able to colonize the open habitat. In fact, they're finding that climax species actually work better in many ways, often a 30 to 70 mix of pioneers and climax species. So this is an assemblage of species that we wouldn't normally think about being good at restoration, but in fact they've shown, and here's an example. This is from Cambodia. This is an area that's been deforested. It's been taken over by dense cover of all kinds of grasses. It burns frequently, and this was the site, one of the sites where this framework species method has been tested. And it's very, very important because Kew gets local collaborators, they build nurseries, they train people. We actually begin to have sort of a critical mass of restorationists in country. And the wonderful thing about the tropics is that they are still wonderfully productive. And this is the exact same site. And in 2 years, you can see it's more than I don't know, 8 feet of growth here. Fantastic cover, spreading, crowding out the grasses. And within 6 years, if you look at the community in cross-section, it begins to develop that complex physiognomy, the layering of canopies that is typical of tropical forests. And by 8 years, we've actually got, 8.5 years, a canopy formed. So this is an amazing transformation of an otherwise impossible site to restore. And at this time, they begin to see many other species come in because of those seed-dispersing birds. So my point here is that this template for doing restoration is now being tested in many places. It seems to be working very, very well. And it doesn't involve all the long years of ecological understanding that we may have tried to do based upon our training as ecologists. It's very, very practical. It's also practical because the cost per hectare is low compared to other methods that have been developed. So here you see methods like accelerated natural regeneration. Well, that's a more inexpensive method, but it's also maybe not as successful in bringing in all of the species that framework species do. The other methods, maximum diversity, mine site amelioration, these are much more expensive cost per hectare. So the point is, early on, we're driving down the costs of doing restoration. And like any product, the first time you do it, it's expensive. And as we do it more and more, we'll find ways of driving down the cost. Institutional constraints. These are just some, and again, I look forward to hearing from my colleagues. I mean, public institutions are basically bearing the brunt of doing restoration now. Government agencies are the ones that give us money to do restoration. But they are subject to all sorts of, as we know, political and policy snafus that hang things up, that make things short-term. They're really not good for anchoring long-term restoration projects. Universities are equally not as good because they tend to emphasize basic rather than applied research. Now that's changing slowly. But still, there's this emphasis on publishing original, often in biology, evolutionarily oriented research. And restoration at this point is not really about that. So universities aren't good for anchoring restoration projects. Private firms, corporations, what I found in my experience in the last 3 years is that the drive to maximize shareholder value is always there. And environment is still seen as an unnecessary or unproductive cost. They will do it when they can, but as soon as shareholder value begins to be eroded by all kinds of other forces in economics, environmental programs and restoration programs are immediately truncated. Oh boy, this is really different. I don't know where the rest of the slide went. Okay, well, financial, and I'll just offer a number of ideas here that aren't on the slide. Grants and contracts. As we know, grants and contracts mostly last 1 or 2 years, rarely greater than 3 years of duration, and restoration projects, there's no way they can be evaluated in anything less than 10 years, and usually, particularly for something like a tropical forest, it is going to take 10 and 20 and 30 years to evaluate. So our funding mechanisms are too short-term. The National Science Foundation, some people are surprised, well, why don't you go to the National Science Foundation to get restoration research funded? But again, their orientation is basic, and I just went on the website to look at all the projects that they've done in the last 10 years, what they consider big discoveries. There's 223 that are on the website, and of those 223 NSF-funded projects, I could only find one that I could link really to a restoration. So, you know, they are really not providing us with what we need. Now, the other factors that were on this slide were having to do with public funding. Public funding, again, coming from government agencies like the Fish and Wildlife Service, like the Army Corps of Engineers, like the Forest Service. They are very happy to fund projects where there's a high probability of making a product, of a successful restoration. But they're less willing to fund the underlying research that would allow us to be successful. So they often say, well, why don't you go to the NSF? Well, we've already been turned away. So those sources, the government has been great in sustaining ecological restoration, but it's really, it's not enough for what we need to do. And finally, the last thing that was on this slide is, you know, the private firms, corporations. And again, in maximizing shareholder value, they often then don't provide the research money that we need so that the effort in restoration is proportional to their impacts. And that's really kind of the standard we have to apply. What is the impact of the mining industry on the planet? What's the impact of the forestry industry on the planet? What's the impact of the livestock industry? And are they giving us the tools in order to reverse those impacts? And my opinion is the answer to that is clearly no. And maybe there are some psychological constraints that involve education and outreach to the public. The first generation restorationists, such as myself, were not trained as restorationists. We were ecologists. It took us a while to fight our way out of that paper bag of always thinking ecologically and thinking about the complexity of the system and how much data had to be collected in order to understand the basics of the system. I think in restoration in the second and third generations, which are being produced now, they're thinking much more practically, and they're sort of backwalking to the more technical or basic research questions that arise. So I think that our education system is changing in order to train restorationists with kind of a new way of thinking, and that's a great thing. It worries me that the general public doesn't know at all about restoration, and every time I talk to a CEO or someone who is very, very knowledgeable about their piece of the world, they really don't know the difference between restoration and reforestation, rehabilitation, and that's a significant deterrent because, you know, why go through all this stuff with species richness and rare plants when you can just stick trees in the ground and that's equally green? We have to do something to change that. That is just absolutely working against us. And I think what's working against us a lot of times is ourselves, that we often hide our breakthroughs and successes. I don't know, maybe we don't hide them, but we certainly don't trumpet them. And, you know, the example that I just heard about, you know, is gee, you know, we can grow now human hair on the back of a mouse, and that's great, or we can grow an ear on the back of a mouse, but that's a breakthrough. That's not a final product. Why don't we announce our breakthroughs? I mean, these products are at least 5-10 years off. Think of the medical industry in general as always announcing a cure for this or a cure for that being developed. So I think we should be less shy about what it is we're able to do. And I think that will begin to address this issue of the general public and their understanding of the importance of ecological restoration. Well, there may be another hypothesis, another constraint that I, you know, was thinking about after reading a particularly significant book that I'll tell you about in just a second. Another hypothesis is that it's a developmental constraint, that ecological restoration as a discipline is less than 50 years old. It may trace back, maybe the first person that was thinking in this way was John Cairn, who was doing mine rehabilitation work in the 1970s. The Society for Ecological Restoration was founded only in 1987 and had their first conference in 1989. The first sort of synthetic book around restoration ecology could be called the textbook, 1990, and then our journals began in 1991. So this is a very young science with a very steep learning curve, as I said, and the first generation restorationists have sort of stumbled around and found some key things, and we're training now the next generations, but we're still on that steep learning curve. The book I wanted to tell you about is this one. This is just published this month. This is Our Once and Future Planet, written by an Irish journalist, Paddy Woodworth. And Paddy spent the last 10 years going around the world, and he's met more restorationists than I ever will meet, I'm sure, as a reporter, as an investigative journalist. And he visited the best and the worst and the oldest and the newest restoration projects, talked to everybody. And one of the things he points out in the book is that this discipline of ours is an adolescent discipline. And like all teenagers, we're really not listened to very much. We have to start maturing in ways that that remove these constraints that I've identified. Kingsley Dixon is the director of science in Kings Park, and he too agrees this is a young discipline. We shouldn't hold ourselves too much in account here, because we haven't had the funding, we haven't had all of the maturation that other disciplines have had. We have our growing pain arguments. Our methodologies are idiosyncratic, meaning, again, they tend to be very place-specific or situation-specific. We don't have broad ways of approaching similar kinds of problems. We don't have yet very many fundamental paradigms of how things work that we all accept. And we have these philosophical arguments that go on in our literature that make us sound a little adolescent. It's not that these arguments are unimportant. They're very important, but they are not the forefront of what we need to do. And as an example, there's two of them. This argument of, well, what reference ecosystem are you going to choose? And another argument is, well, maybe we should just accept novel ecosystems. So let me illustrate those. This idea of choosing a reference ecosystem. When you do a restoration, there's always this argument, well, are you restoring to current conditions? Are you trying to go back in time, to before fire suppression, for example, in California oak woodlands, before invasion of the European annual grasses, before livestock were introduced? Where along that timeline do you want to restore to? Or do you want to restore something novel that has no historical precedent but somehow accommodates climate change? That is a big argument, and it still goes on. And I kind of think, in a way, we're kind of worried that we're going to get in a time machine and do a heck of a lot of damage that can't be reversed. I don't think that's true. Okay? I think that we should not worry about timelines so much, but worry about whether or not we have the tools to push ecosystems predictably in certain directions, that we have sort of flexible criteria for restorations, like being able to push an ecosystem towards being more native or having higher diversity or being what I'm calling pan-functional, meaning being able to accommodate multiple functions. You're not going to exclude grazing in the modern world, but maybe is there somewhere you can reconcile grazing to oak regeneration or to wildflowers? That's what we need to do. Those are the flexible criteria that we need, not so much choosing an ecosystem and trying to push it back in time. Another growing pain argument is this idea of novel ecosystems that have no historic reference. Maybe we should just accept eucalyptus forests, whether they're in California or in Kenya, as a novel ecosystem that's here to stay and that we should not even try to do anything with. We all know this, it has consequences, that eucalyptus is an amazing tree. I mean, it's very, very productive, but it does that at the expense of the hydrology of the soils. It does that at the expense of the system itself, that it creates biological monotony. And then this is eucalyptus in Kenya replacing what was once upland forest. And in that stand, in the particular stand, the biologist recorded just 32 species of birds. Should we accept this as a reasonable analog for the future? Well, my answer to that is no. We've only started to look at restoration of Kenyan upland forest. And this is a very small botanic garden, Brackenhurst, outside of Nairobi. They have replaced eucalyptus and acacia and in 10 years created an analog, not a perfect analog, but an analog of Kenyan upland forest composed of native species. Just in 10 years, again in the tropics, the canopy is more than 12 meters tall. It has a complex physiognomy. They've worked with 500 plant species, getting the diversity back in, and now in a relatively small stand, about 10 hectares, 170 bird species are now observed. So we're capable of this. It doesn't seem like we need to accept yet the defeat of novel ecosystems. We don't want to accept this idea that anything that grows green and functions is a good restoration. So are we going to restore to some historically defined standard, or do we simply restore functionality with available tools and talent? I think that the world would become a very depleted place if we accept that argument today. So how do we go on to the next level? Well, that's a very open question, and I don't pretend to have the exact answers. I think maybe we have some combination of arenas that we need to work in on national and international levels. And those arenas are these, maybe not the only ones, but technology, developing the technology of what we do, developing the infrastructure that supports restoration activity, and developing the opportunities to do restoration on the important time and spatial scales that matter. And I can't talk about all of these sub-ideas. I will mention some. I've already mentioned one under technology, the idea of standardizing restoration templates. But under infrastructure, having a stable institutional home for restoration projects, always outreaching to the public and to legislatures about what it is we're able to accomplish, exchanging expertise globally. And under opportunity, I think we really have to keep pushing partnerships with extractive industries, those industries that have a major impact. And this will hopefully lead to this sustained funding to bridge this divide between basic and applied research. So let me just illustrate a few of these. I won't talk about automated eco-sampling, but drones can be used for good purposes as well as bad purposes. And people are developing drones now that could actually do botanic surveys, that can do, of course, vegetation mapping, but now actually go out and look for rare plants. And I've worked a little bit with this myself. But I'll talk a little bit more about standard restoration templates. I've already talked about one, the framework species approach. And the framework species approach, something that can be applied in many places. It really is about secondary succession, meaning there's a soil that is intact. It hasn't been disrupted. And again, the example that has been done is in Cambodia, very successful. It's now being done in Kenya at extending the Brackenhurst experiments. It could be done and applied in temperate ecosystems as well, but as of yet has not. When we have a really tough restoration issue where we're dealing with a disrupted soil, maybe a new soil that was never there before, we're really kind of talking about primary succession. And here we need a new set of tools and a longer sort of vision or bigger vision for how to do this. So the idea that's been put forth for the mining industry, particularly in the tropics, is the idea of disassembling an ecosystem, knowing what all of the species are below ground and above ground. And that includes the bacteria and fungi, as well as plants and animals, the dispersers. We now have the capability to do that kind of survey, knowing all of those species, and then searching statistically for the most powerful interactions between species, between fungi, let's say, and the roots of overstory canopy plants. Those things, those interactions are what we want to restore. So it would be a way of getting a subset of critical interactions in a soil that has been destroyed and then rebuilding them, perhaps in an experimental framework. So if I were to illustrate disassembly and then reassembly, the disassembly comes in stages. Here in the tropics, we may have many, many kinds of species. And what we would want to do is GPS, know spatially the relationship between the soil biota and the overstory canopy, know what species are in the canopies, who are the dispersers, who are the ones that disperse fungi like many ants do in the tropics, or bird dispersers for seeds, but really concentrating on below ground, above ground interactions. Once we've done that, particularly with sensitive species that are meaning sensitive to our disturbance, to our contamination on the bottom of our shoes and all that, we go in and we begin to map the structure of the vegetation. And this now can be done very easily with LIDAR. And again, we're going to do GPS reference, so we have a three-dimensional image of what the ecosystem looked like. And then what we're going to do is take it apart. And the reason we can do this in a mining operation is they're going to take it apart anyways. It's just that they're going to do it all in about a week's time, and they're going to make a big pile of stuff out of it. We're going to take it apart systematically, and again, do it in a geographically referenced way, so we know about those potential ecological interactions. So we can take down the canopy. We can do it sequentially. We can get carbon sequestration data, which is so important. We can find out, you know, all this regulation that's been done on carbon sequestration in forests is based upon carbon storage of 8 species. 8 species. Whereas a forest in Madagascar, a single forest, a stand, maybe just a few hectares, will have 400 tree species in it. And they all have different densities of wood. They all have different abilities to sequester carbon. So we could get those kinds of carbon sequestration data by taking apart the forest and biometrics and using biometrics. And then we can take apart the soil as well. We can store it in piles. We can study its the ability of microbes to maintain themselves. There's a lot we can learn by taking the soil apart in a systematic way. Now, this idea of disassembly is coming about because of operations in different places in the tropics. The mining industry has access. This is an example in Madagascar where we've got a very, very rare forest now, maybe down to 1 or 2% of its original distribution. It's called littoral forest, meaning along the coast. Very species rich. And it sits on top of these what are called ilmenite sands. And ilmenite is the precursor to titanium. So they are taking down, in their own way, this Madagascar littoral forest for titanium. And we have been trying, unsuccessfully, to sell this idea to them that why not let us take it apart. And again, we're still sort of hammering on that. The mining industry, maybe some of you know, has gone through a contraction within the last year or so based on the fact that the Chinese economy is going to grow at only 7% instead of 10%. And so they begin to revise all their economic models and basically say, oh, we can't do anything environmentally now. Okay, it's about shareholder value. That's kind of a false argument. I mean, this mine is going to be here for decades. So we need to get them to thinking longer term. And right now what they are doing is, with this mine, is that they are doing what they call rehabilitation, which is to get any kind of plant cover on the tailings. And what you're looking at here are mountains of post-mining tailings and planted with casuarina, which is not a native tree. Now, this is important locally because they are obligated to produce fuel wood. But there isn't any reason that they couldn't use native hardwoods in this. It's just that they haven't done the research to know how to get those hardwoods to grow on this post-mining substrate, this substrate that's been effectively sterilized. And what they are getting then out of this planting that they're doing with casuarina and eucalyptus and acacia is a novel ecosystem. And so the question is this what we accept instead of Madagascar and littoral forest? And, you know, they know they're under pressure to do better. Whether they will, given the economics, is a big question. And the reassembly part of this I won't have time to talk about, but basically, again, large plots where you could vary the species that you put back. You can inoculate some with mycorrhizal fungi if that turns out to be a significant interaction below ground. You can study soil storage. You can look at organic matter additions. This is the way we would learn to put back. But again, we're talking about a long time framework here, that an experiment like this minimally is going to last 10 or 15 years. Infrastructure is really important to growing the discipline. And the most important, I think, of these is the stable institutional hosting. I've already said universities aren't so great at hosting projects. Government isn't so great. Private firms, not so great. I think the answer is that to get places where projects can sort of be handed off as careers are handed off, we need something like a botanic garden. And so I think that the most important places on the planet for doing restoration, particularly long-term projects, are botanic gardens. And so part of what I've been working on at Kew is getting botanic gardens to form what's now been called the Ecological Restoration Alliance, the ERA. And the ERA is kind of founded by these major gardens, and we're inviting other gardens to come join us. But Kew, the Royal Botanic Gardens in Edinburgh, Kings Park, which is in Australia, and the Missouri Botanic Garden here. And of course, Santa Barbara, we want on board as well. There's botanic gardens all over the planet. This is a BGCI, the Botanic Gardens Conservation International. This is their map of where botanic gardens are. And of those, there's about 100 that self-identify as doing restoration right now. So this is the sort of the core of the ERA. And again, that paper, the 2011 paper, The Role of Botanic Gardens in the Science and Practice, that's basically laid out a blueprint for drawing these gardens together. So we began to meet. We met at a large garden, New York Botanic Garden, in 2011. We met at a small garden, Brackenhurst in Kenya. And we put together then the framework for this. We put together the program, what we want to do, and how we're going to do it, and how we're going to get it funded. So we developed a memorandum of understanding. It was signed at Kew in 2012, and we had a wonderful party in the House of Lords in Parliament. We had a wonderful endorsement, a video endorsement by Prince Charles, and we have a website launch, which is going to happen any day now. And that video of Prince Charles is going to be on that website, as well as projects that are being done by Botanic Gardens as we speak. We've already done the fundraising. We have our first funded project, which is between Kew and Brackenhurst and Turo, which is in Uganda. And basically what's going to happen here, the Ashton Trust has funded the use of the framework species method to take advantage of what Brackenhurst already knows about all those species and how to put them back. We're going to do it now in with a little more scientific rigor over larger spatial scales. And so this is our first sort of what we're calling a polygon of cooperation, a large garden like Kew hooking up with small gardens in other places. And lastly, I'll talk about this opportunity that is so important. I mean, obviously funding is always limited. How do we make funding available and how do we sustain it? So I think the only answer is to keep hammering at these extractive industries, mining, timber, livestock. It's really important that they step to the plate here, that they are constantly disturbing the complex soil and plant interactions that occur on shrinking islands of intact ecosystems. So the question for those industries, the reason they might come to the table is they have to answer this question. Are they going to be given access to resource lands in the future given their track record of rehabilitation today? Will they adopt a standard that's higher than rehab? Will they go to a restoration standard? And it's already starting to happen that many projects now around the world are being rejected or contested for environmental reasons based upon the history of what mining has done. And this is just a few. Companies like Vandata, Anglo-American, Beacon Hill Resources are being turned down. And Tom Albanese, who just left Rio Tinto as the CEO, has put it very nicely, increasing opposition everywhere we go. We're in a death spiral as an industry. This is the reason they might come to the table. And I'll make a note here, just a sideline. I have been able to get into these meetings within certain mining companies to hear their rehab people talk about what drives their own processes forward. What is significant? What significant pressures come upon them to do a better job? And what they all said universally was that if it wasn't for the NGOs, if it wasn't for the conservation groups, if it wasn't for the people that write letters objecting to what is going on, they wouldn't do anything. But when they get those letters, when they get the threat of a lawsuit, it really sends a shockwave through the industry. So I'm telling you that they talk about this, and it is really, really important to send those shockwaves. I think that's public participation in this is absolutely essential. Another thing we've been trying to work on them with is to, again, instead of putting rehabilitation and restoration off to closure, and what this is a diagram of is sort of the operation of a mine. The x-axis on the bottom here is sort of the life of the mine, going from 0 years to 60, 70 years when the mine is finally spent, and the amount of activity and what activities occur along that timeline. Well, normally they put off rehab and restoration to the very end. And there's economic reasons for doing that, and there's also just sort of human reasons for doing that. The guy right now doesn't want to worry about that time in the future. So we've been working with them to try to push rehab and restoration back into the mine planning time. And again, that's when you could do a project like disassembly, reassembly. That's when it should be done. When you've got an ecosystem available that's going to be destroyed, you can take it apart and learn more about how to put it back together again. And finally, opportunities is also about sustained funding. Again, I can't emphasize this enough. The industry needs to match its investments in restoration proportional to its impact and also to its rhetoric. And you hear a lot of rhetoric from extractive industries about environmental importance and the good job they're doing. Well, we can sort of gauge that by what their investment in research is, I think. And ultimately, as Tom Albanese from Rio Tinto has pointed out, that shareholder value is not just going to come from net profit of the mine in this quarter. It's going to come from access to land and what the company is able to do in the future. And so somehow we have to get that message through to shareholders. So again, this transition from a regional discipline to a global practice just requires thinking a little bit larger than maybe we're used to thinking as scientists. We have to think sort of strategically in these three realms at least, and perhaps in other realms as well. Thank you very much.